center. 10 tunnel boring machines will excavate through rock and soil to build the tunnel walls. 6 machines are designed specially for Kuala Lumpur's challenging geological conditions.
You can say it's very special because no machine has been designed like this before.
Rise to the challenge. 10 machines are used.
Tunnel boring machines are essentially cutting tools for the ground. You can refer to them as a mole. Most cities now, for railway, the tunnels are built using TBMs because of safety issues and because of ground conditions.
Overall, the ground conditions along Sungai Buloh Kajang Line underground section consist of the Kenny Hill Formation and the Kuala Lumpur Limestone Formation.
Kenny Formation is actually consists of weathered sandstone or mudstone. So it is very predictable and the profile is very consistent.
For this section, 4 conventional earth pressure balanced TBMs are used.
KL Karstic Limestone Formation is one of the most difficult ground conditions for tunneling. So from the experience that we learned from SMART, we sent our team to Germany to work with our supplier to develop a machine capable of handling this type of situation, which is now known as the variable density TBM, and it is the first of its kind in the world.
The new machine, called the Variable Density TBM, was a result of a combined initiative by Malaysian tunneling experts from MMC Gamuda and Herang Knecht of Germany.
It's a product of ideas, opinions and experience from all quarters. It's a very comprehensive machine. You can say it's very special because no machine has been designed like this before.
This TBM
throughout the whole process, and second is to control the vibration and sound to the allowable limit so that it will not induce any damage to the surrounding building.
Excavation of the shaft took approximately 9 months to complete. The first variable density TBM arrived in Malaysia in late January 2013. Transporting the TBMs to the sites through Kuala Lumpur was a challenge that needed detailed coordination. Precise planning was required for the assembly of the machine, as any damage would require custom repairs in Germany.
This is a very complicated machine. And we are also dealing with very delicate components, very heavy, looks very tough but very delicate. We cannot afford to damage it. If the extent of damage is huge, then the impact to the project will be tremendous.
At the Inai shaft, 2 variable density TBMs have been launched. The circular shaft was excavated to a depth of 34 meters. At the bottom of the shaft, chambers were dug to allow for the assembly of the TBM. Due to the tight space conditions, lowering the parts of the TBM was extremely challenging, especially the screw conveyor.
It's the most difficult one because this length is actually bigger than the shaft itself. It's 18 meters long. The shaft is 17 meters. Any damages caused to this component would cause a major setback to the project and definitely to our launching.
The launch of the first variable density TBM was officiated by the Prime Minister of Malaysia, Datuk Sri Najib Tun Razak, on 30th May 2013. Each ring consists of 7 segments and 1 keystone. Segments weigh up to 2.2 metric tons and are lifted by a vacuum system. The ring builder controls the giant hydraulic arms of the erector to position the segments down to millimeter precision. A total of 11,500 rings are needed to line the dual 9.5-kilometer tunnels. Tunnel walls need to be strong enough to withstand extreme pressure and chemical attacks from the ground and water, and to also endure settlement caused by poor ground conditions. The tunnel segments are manufactured off-site at 3 different factories.
We are adopting the technology what we call steel fiber reinforced concrete. We use a staple-like steel fiber to replace a conventional thick and heavy rebar. On top of that, we are using another fiber called polypropylene fiber to improve the fire-resistant properties of our segments.
At certain stretches of the tunnel where reinforcement is required, segments which can withstand extra load were designed.
What you can see here is the hybrid system. When I say hybrid system, means we'll have this rebar in, and at the same time, we'll pour in steel fiber reinforced concrete to cater special geological conditions like crossing Sungai Kerayong or for the SEC tunnel.
The segments are transported to the TBM using multi-service vehicles. As the TBM mines deeper into the ground, the temperature and humidity rises further. Giant fans pump cool air into the ventilation duct that stretches all the way to the TBM. The tunnel is like a giant artery feeding the men and machine with vital supplies: cool air, power, water, grout, and a crucial material, bentonite slurry.
Here is going to push this slurry all the way up to the surface, especially in shallow condition. And secondly, with a high viscosity, we slow down the losses of bentonite in the very cast condition in the limestone. In the normal slurry machine, the slurry will lose out so fast, we will be delayed in the machine's response in injecting sufficient slurry back to counteract the losses.
The slurry also carries the mined waste out of the tunnel. Above the ground, a massive slurry plant is working around the clock to process and clean the slurry coming from the TBM through a series of screens.
What the separation plant has to do is to ensure that the screens are all working perfectly, there is no clogging in the screens, and to make sure that all the conditions of the motors and also the screens are in 100% good condition.
The cleaned recycled slurry is then piped back underground via giant pumps to the TBM to start its journey all over again. After mining for a certain distance, the TBMs need to stop for servicing and maintenance, and this is called an intervention.
We're having this intervention stop to have a check on the cutter discs. Cutter discs are like the knives of the machine that cut through the ground. So we're just going to check whether we need to change them or not so that we can further mine.
The cutter head lies in the forward pressure zone. Before any work can be carried out, tunnel engineers first need to determine whether the ground conditions in front of the cutter head is safe.
The first thing I'll be concerned
Think part of Kuala Lumpur. An example is we have one station located where the Warisan Merdeka development is going to be done. In that particular station, we have the Merdeka team, where we incorporate features like the Rukun Negara and also pictures of Merdeka. We have another location, which is at the TRX. So there is a financial feature. At the end of the day, we want to make this fun as well, something that people can relate to.
On 24th April 2014, the underground team celebrated their 5th TBM breakthrough, accomplishing more than 50% of the underground works.
If you look at the progress so far, it's been extremely encouraging. And, my congratulations to Gamuda for working, with HARUConnect to actually come up with this TBM. And I think with what has been going on, with the breakthroughs that we've been having, I think it's been worth their while, and it's really paying off. We've brought the underground work to a very good pace, and it's testimony to all the hard work that's been put in by the team.
It has been tremendous, unforgettable journey. The machine has performed very well. So, combination of machine equipment and good people, our engineering crew, our operation crew, the academy boys, and our young graduate engineers that have
perform all beyond par. It is an incredible achievement, not only for me, but for the